So I know it says 8.3 as well. Sure, we can call it 8.3, we can call it 8.1. Let's just call it 8.3. We're just doing them out of order. Here's the law of cosines. So part of it will be familiar. C squared equals A squared plus B squared. This is the first part of it. Does that look familiar?
Yeah.
Yeah, that's the Pythagorean theorem, okay? We're going to add a second part. Minus 2AB cosine C. And so for our triangles here, if we have triangle A, B, C, capital letters A, B, and C, then the sides opposite those angles are called lowercase a, b, and c. So uppercase are the angles, lowercase are the sides. Okay, so in terms of memorizing this, something to notice here is there's a little bit of symmetry, like side C is right there, cosine C is at the other end. It kind of bookends it. And then if you have A squared plus B squared, you have A and B right there. And then this -2, like, I don't know, it's just right there in the middle. So just remember that there's a -2. Because there's actually two other versions of the law of cosines where the letters are swapped around. Because what this helps us do is it helps us solve for sides of or angles on triangles based on what information we have and what information we don't have. So here's the other version. A squared equals B squared plus C squared. And the other one is going to start with B squared equals A squared plus C squared. And so we're going to follow the same pattern here that if we just use the letters B and C, this is -2BC. And then if it's A squared on this end, we have cosine of A. And then the other version follows the same pattern too. So there really is just one law of cosines, but we're going to be looking at triangles that are always labeled A, B, and C. And so just depending on how they're labeled and what we're given and what we're not given, we have three versions that we're going to get familiar with, but it's the same pattern in all of them. So law of cosines helps us find missing sides or angles when we are given this information, side, 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 or side, angle, side. So thinking geometry connections here. So let's just look at number 1 here and we'll see what that looks like. So we start by drawing a triangle. We can label it A, B, and C. And so B we see as 42 degrees. Side A would be over there, opposite angle A. And then side C would be right there, opposite angle C. So obviously what we're missing is angle A, not angle B, angle C, and side B. That's what we're missing. Oops. So notice the arrangement of our given information. It goes side, two sides, with the angle in between. So this is like a side angle side arrangement, which is a situation that we can use law of cosines for. Law of sines kind of covers the other arrangements. Angle, side, angle, 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 side, and even the infamous angle, side, side, which is what makes it difficult. You don't have to worry too much about which laws work for what, because if you don't have the correct arrangement and you try to set up the equation, it's just not going to work. You're just not going to have the information. So don't worry too much about memorizing that this is only for side, 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 or side, angle, side. Like, you'll get the hang of that kind of automatically. So let's just do it. Here's how it goes. We're going to solve for b first. So we're going to use this version right there. So we've got b squared equals 12 squared plus 15 squared minus 2 times 12 times 15 cosine of b, which would be 42. If we're trying to solve for b, what would we do?
Square the 12 and 15.
Square the 12 and 15 if I'm trying to solve for b? How do I get b by itself? What's that?
Square root.
Square root, yeah. If I square root everything, that'll give me b. Okay. Now, if I have a calculator, do I need to do anything else to solve for b? Besides just move my fingers, right? Or thumbs. Yeah. Okay, so again, we'll do some calculator time, but I want to show you what this would look like here. Because if you have Desmos or if you have a graphing calculator, these calculators are amazing because they allow you to do everything all at once. So if I say b equals the square root of, I can just do 12 squared plus 15 squared. I'm going to turn so I can see here. Minus 2 times 12 times 15 cosine 42. And I'm going to make sure that I'm in, oops, no, where's my settings? Over here. Degree mode. And so we get b equals 10.073. We're always going to do 3 decimals. That's just the preferred way. Now, something that's actually really great about Desmos, and the TI can do this as well, but Desmos is just easier. Desmos is user-friendly in a lot of ways, is I could do A equals 12 and C equals 15 and capital B equals 42. Like, Desmos does distinguish between capital B and lowercase b, something the graphing calculator can't do. And so if I say B equals the square root of a squared plus c squared minus 2ac cosine b, it is going to just give me the answer using the letters. So this is really handy, especially like on a test if you have to use the law of cosines a few different times. Really easy to go back and just like swap out the different letters that you need, or like, oh, I'm doing a different problem. In this problem, c is 17. So this is why I recommend you use Desmos. There's a special Desmos that you're going to use. I put a link on Schoology. It's got this green banner. This is the testing version. Other regular versions of Desmos can actually sometimes do the law of cosines for you. You can just say like law of cosines, these numbers, and it'll just give you all the missing stuff. So that would really defeat the purpose of teaching it to you. But it's cool that we exist in a time where that's a possibility. So you guys actually need to know how to do the law of cosines, but we're going to use this Desmos right here. So anyways, but that's a great feature. And now, like, if I type b later, like b equals, or I just use b, I don't know, b plus 1. Oh, no, maybe not. I thought it would store this as b. Who knows how to use Desmos?
I think it's because it's also up top.
Oh, it's in 2 places? Yeah, very good. Even though it was in two places, it was the exact same thing. Okay, so you just need to have one instance of B. Good to know. Good to know. Okay, so we're going to go back to solving this problem. We'll just pretend that everybody used Desmos instead of just me. So B equals, what was it, 10.073. 073. Okay, cool. So we're still missing two things, right? We're missing angle A and angle C. So here's what we're going to do. We're going to use the law of cosines that has angle A in it and angle C, and we're going to solve for those angles. So as we set that up, let's see. Let's put a little barrier here. You guys want to do A or C first? A, great. So we say A squared, so 12 squared, equals B squared plus C squared. So I'm going to use the letter B to represent 10.073. Like if it's stored in my calculator, it's going to use the full decimal, which will be better. So B squared plus 15 squared minus 2 times B times 15 cosine of A. Okay. We need to solve for angle A. Turn to your neighbor. How do we do that? How do we get angle A by itself in this equation? Okay, how do we solve for A?
Move everything except for 8 towards the other side.
Okay, in what order? You're right.
From
What would be my first step?
left, right.
What would be my first step?
The B squared and 15 squared.
Okay, what would I need to do with them?
Like 12 squared minus B squared minus 15 squared.
Yep. Okay, so we have 12 squared minus B squared minus 15 squared, and that equals negative 2 times B times 15 cosine A. That's exactly right. Okay, and then? Divide? Yeah, divide by what? Yep. Okay, so we have 12 squared minus B squared minus 15 squared over negative 2 times B times 15 equals cosine of A. Okay, all we're doing is algebra 1, right? We're trying to isolate the variable, so we're working reverse order of operations. We have to subtract first, then we divide. Okay, now we're doing geometry. How do we uncosine something?
Cosine inverse.
Cosine inverse, right? Exactly. So cosine inverse of all of that and that will equal A. Okay. This is when you get out the calculator. Not you, but this is when, in theory, you would do it. Put this into the calculator. So you don't want to do it step by step because this is complicated. There's a lot of numbers here, and if you mistype something along the way, and you're doing it like in 100 steps instead of all one step, like it's hard to go back and fix your mistake. Whether you're using the TI or you're using Desmos, it's really easy to just type this in as one step. And it's really easy to check your work and make sure it's good. So Since I've already used B and A and C and all these things, I'm just going to say, oops, start typing in my other screen. Cosine, and we just like do it to like the power of -1, which is not really the power of -1, but we do just the superscript. Or you can select it from the keyboard, but you can just type it too. Make a fraction in there, and then do everything we need to do. So I can use 12 squared minus b squared, or what else could I do? I can use a and b and c that I have before, right? So it doesn't matter, whatever's easier. Definitely use b squared because it's a long decimal. We don't want to round that until the very end. Divided by -2 times b times 15. Okay, and so there's our angle right there, 52.857. Degrees. Make sure you put degrees because we've been doing degrees and radians this year, so we have to make sure we tell the difference. Now, if you ever enter something wrong, like if I forget the negative sign, it's going to mess me up. Or sometimes, just kind of depends on what's going on here. Okay, sometimes you might get a result that says something like this, undefined. This is if the value inside of cosine inverse is greater than or less than 1 or -1. Because we know, we just did a whole unit on this, we know that the cosine graph, the highest point is always what? What's the highest point of our cosine graph? Yeah, 1, and our lowest point is?
-1.
And so we can never have cosine inverse of 2. Where does cosine equal 2? Nowhere. Okay, so it always has to be between -1 and 1. So if you type something wrong, this happens all the time. It'll be the middle of the test, someone's like, it keeps saying it's undefined. And I'm like, yeah, I know. You're typing it wrong. So if you type it right, it's going to work out. But just pay attention. Desmos is really easy to not make mistakes. You just look at it. The TI is a little clunkier, a little less user-friendly. So again, this lesson sponsored by Desmos. Just use it. It's easier. Okay. When we're solving for angle B, what would we do? Turn your neighbor, what would we do to solve for angle? Sorry, C, angle C. Same thing, right? Okay, set it up, do it. Set it up. And we'll type it in, make sure it works. Okay. Did you guys get this? Now look at our two cosine inverse fractions here. What's different between them?
The top bit.
Yeah, instead of 12 minus b minus 15, we have 15 minus b minus 12. So what happened? 12 is negative, 15 is positive. We just switched them, right? We just switched them. And then on the bottom, instead of 15, what do we have?
12.
12. Okay. So all we did was, because we're using the same law, just with different arrangements, we just switched the 12 and the 15. 15 is side C. So we care that C is first. We subtract the other two. But if we just look at this one, we switch all the 12s and 15s. So it's actually pretty easy to do like on the calculator, because all I need to do is go back here and I can change the 15s to 12s and the 12 to 15. And there's my angle right there. Now, actually, here's what I should do. I should say this, when I first set this up here. For the last one, this was angle A. I say A equals. And then I can say C equals, and I can just copy this and paste it, change those. And then what I like to do at the very end, just to make sure I've done everything right, is add up A and B and C, because they should equal what? They should equal 180, because they're the angles of the triangle. Now, we could have just solved for C by subtracting the other two answers from 180. The only risk is, what if we made a mistake? Doing something, did it take a ton of time to do law of cosines again? Especially on the calculator, it took like 2 seconds, right? So take a little bit of time to do the law of cosines to find the other angle, and then just check and make sure that angle, all your answers are right. Because, like, if I forgot to change that one, and my angles add up to 180.9, I know that there's a mistake somewhere. So it helps me find that mistake. Okay. Questions so far? Not that bad, right? The other situation we might get is when we're given all three sides. But my process for finding all three angles would be the exact same as what we just did to find our angles. So we basically just did this, but I would set it up for each one. So like for angle A, I would do 11 squared equals 14 squared plus 21 squared minus 2 times 14 times 21 cosine A. When I solve that, I know I'm going to get A equals cosine inverse 11 squared minus 14 squared minus 21 squared over negative 2 times 14 times 21. And I would do the same for all the other ones. So that's what the B equation would look like. When I solve it, it's the same thing. And then I could do it again for angle C. But if I'm paying attention, hopefully I'm noticing which numbers are switching. So if we're doing C, then side C should go first. And I should have sides B and C on the, or sorry, B and A on the bottom. So I might not need to write out the whole equation every time. You do need to show what you're typing into the calculator. But when I actually go to solve this on the calculator, it's going to be pretty easy. I'm just going to be changing a couple digits here and there and doing that. Okay, I want you guys to do finish number 2 and then do number 3, and you can use your calculators now. Let's do it. Ready, set, go. All right, guys, let's just check in here and check number 2 real quick, and then circle back in another couple of minutes. Check number 3. Look what I did here in Desmos. So I said A equals, let me just delete those for a sec. A equals 11. I'm going to type in C equals 14. I'm going to type in B equals 21. I've got my 3 cosine inverse equations right here that are set up using the law of sines. So I've got, for angle A, I have A squared minus B squared minus C squared over negative 2BC. And then for C, I'm just switching the letters A and C. And then for B, I was switching from the first one, the letters A and B. And then once I type in C equals 14, it's going to tell me what all of those angles are, and then I've just got a little check down here to make sure that A plus B plus C equals 180. So I got A equals 28.652, C equals 37.608, and B equals 113.741. And so that's how we can use Desmos to the full capability there. And it didn't take very long to type this in because I just did Control C, Control V, a little copy paste. Any questions on this process here? Okay. When I start doing number 3, I notice that I am given sides for A and B. And so I could change those here. First of all, notice that as soon as I delete like one of the digits for A, all of those become undefined. Does anyone know why that is? If we have sides 1, 14, and 21.
Because the results in the parentheses equal greater than 1 or less than -1.
Yeah, that's true. What is it about the sides that is causing that to happen? If I have a triangle with sides 1, 14, and 21, yeah.
Like it just doesn't work because it doesn't like fit Pythagorean theorem.
Well, it's not a right triangle, so it doesn't need to fit Pythagorean theorem. It doesn't work though, obviously, but for another reason.
The sides like don't equal 180.
Sides don't add to 180. Could I have a triangle with sides length 1, 14, and 21? Obviously not, but why not? Think about drawing that. This is something you can't explain in geometry, but it will make sense to you guys now. If that's 1 inch, 21 inches, quite long. 14 inches, like it's just not going to reach, right? That's a pretty aggressive looking 14. It's probably longer. This is roughly to scale. Are those two ever going to touch? The 21 is like way too long. So remember, in a triangle, the 2 shortest sides have to add to be longer than the 3rd side. That's called our triangle inequality theorem. Okay. So as I'm setting up number 3, here's what I'm going to do. I'm going to set A equal to 22. I'm going to set B equal to 20. And I'm going to set C equal to the square root of A squared plus B squared minus 2AB cosine of 95. And I'm going to delete this thing here or I just won't call it angle C anymore. And then look, I've got, what did I need? Side C is right there. Angle A is right there, and angle B is right there. Whoa, I just did number 3 really fast. Now we don't have an angle C, so this isn't going to work anymore, but can put it in 95. Okay, so that's what we can do with Desmos. The TI graphing calculator can do that as well, just is a little slow. So as we're checking our answers, we should be getting A equals 44.998 and B equals 40.001. Questions on that process? Okay. For homework tonight, you're going to have an option of Delta Math or paper homework.